Hi, welcome to my video on solving ax squared plus bx plus c equals 0 when the roots are non-real. That means the roots are going to be imaginary with the I because it's a square root of a negative number. What if the number underneath the square root is negative? The square root of a negative number is not a real number. The square root of negative 1, written square root of negative 1, equals I, and it's an imaginary number by definition. Let's do some examples. And the imaginary numbers, there's a unit on Algebra 2 on 3 videos on imaginary numbers, and there's also a unit on the complex numbers. They should be reviewed and go over to make a little bit of better understanding of what's happening here. The square root of negative 4, well, the square root of 4 is 2, and because it's negative, we have an I, because it's understood to be 4 times negative 1, which is the root of 4 times the root of a negative 1. Square root of 4 is 2, and we have an I, so 2I is the same as 2 times I. Square root of negative 25 is a 5, and because it's negative, is an I. The square root of negative 18 is going to have an I, but 18 is 9 times 2. So that's a 3 root 2. And we have to put an I, and I put the I in front of the root, not behind it. So if you wrote down 3 root 2I, well, you can check with your teacher, but most times it's 3I root 2. Solve x squared plus 4 equals 0 by. Now we're going to solve this quadratic, which has 2 roots, by factoring. Notice we have the sum of 2 squares. Notice we have an x being squared plus a 2 being squared. And we cannot factor the sum of the 2 squares over the real numbers, because notice that there's x squared plus 0x plus 4 equals 0. Notice that there's no x. That means the b is 0. So if you think about it, what 2 numbers can you multiply to give you plus 4 and add to give you 0? Well, there's no real numbers to do that. So we have to factor the sum of 2 squares over the imaginary numbers. And the factorization is, if you think about it, well, we have an x squared, which is an x and an x. And we have to have a plus and a minus. The square root of 4 is a 2 and a 2. So it's very similar to the difference of 2 squares, only we have to have an I. So if you take x plus 2i and multiply by x minus 2i, then I'm going to multiply this out now to show you. X times x is x squared. X times negative 2i, negative I at 2x, and a positive 2i times x is a positive 2ix, and a positive times a negative is a negative 4i squared. And notice that the middle terms cancel out, and also I squared, based on the unit we did on complex numbers, I squared is a negative 1. So negative 4 times negative 1 is a plus 4. So this is the correct factorization of the sum of 2 squares, but it got to have an I. That means we have an x plus 2i equals 0, or x minus 2i equals 0. So x equals negative 2i, or x equals a positive 2i. So there's 2 roots, but they're imaginaries. Now let's solve the same one by what we call the square root property. And the square root property, well, watch what happens. Notice that the 0x is missing. That means that the b is 0. That means we can move the plus 4 over to make it a minus, and we can do the square root of both sides. When we do the square root of both sides, we had to put a plus minus there. So the square root of x squared is x, plus minus. The square root of 4 is a 2 with an I. So that's doing it with the square root property. And just to back up the quadratic formula, we got an x plus 4 equals 0. So x squared plus 0x plus 4 equals 0. Because when we use the quadratic formula, we got to have it written as a x squared plus bx plus c equals 0. So that's why I wrote a 0 in for the x term. So a is 1, b is 0, c is 4. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And b is 0, so it's the negative of the 0, plus or minus 0 squared minus 4. A is 1, b is 4, all over 2 times a is 1. And that gives me, let's go up here, that gives me the negative of 0 is 0, plus or minus 0 squared is 0, so that gives me negative 4 times 1 times 4 is negative 16, all over 2. 0 plus or minus, the square root of 16 is 4, and because it's a negative, we do an I over 2. So that's 0 plus 4i over 2, or 0 minus 4i over 2. So that's 4i divided by 2, which is 2i. And we have negative 4i divided by 2, which is negative 2i. So I did the solving of x squared plus 4x by 3 different methods: by factoring, by the square root property, and by the quadratic formula. And they, each one of them obviously came, I won't say obvious, but came up with the same answer. Now, solve each. So what I'm now doing is helping you review the different properties, because again, it helps you keep everything in line with practice. Solve each by the square root property. So the square root property, x squared equals negative 36. We move it over. We take the square root of each side, plus minus. Don't forget the plus minus because there's 2 roots. Square root of x squared is x, plus minus. Square root of 36 is 6, and because it's negative is an I. Number 2, we got to solve it for x. So negative 3x squared equals 75. Divide by negative 3, and I get x squared equals negative 25. And we do the square root of each side, plus minus. X equals plus minus square root of 25 is 5. Because it's negative, we have an I. Again, the 2 roots. So that's 5i or negative 5i. This is a 6i or a negative 6i. And solve these by factoring. Factoring means 2 brackets. So this is the sum of 2 squares. So it's brackets. You can't factor the sum of 2 squares over the real numbers. So x squared is x and x, plus minus. Square root of 9 is a 3 and a 3. But if we multiply that out, we get a negative 9. So we have to put an I, because this is being factored over the complex numbers, imaginary numbers. So multiply. Note, you get a negative. If you multiply these 2 right here, you get a negative 9 I squared, which is a plus 9. Perfect. So x plus 3i equals 0, or x minus 3i equals 0. X equals negative 3i, or x equals positive 3i. And number 2, again, notice we got a 2x being squared plus a 7 being squared. So we have the sum of 2 squares, which we cannot factor over the real numbers. We have to use the imaginary numbers. So that gives us a double bracket again, same. 2x, 4x squared is 2x, 2x. 49 is 7 and 7, plus minus, but we have to have an I in order to make it positive when we multiply. So we got 2x plus 7i equals 0, or 2x minus 7i equals 0. 2x equals negative 7i divided by 2, and x is negative 7 over 2i. And this one is 2x equals 7i. Divide by 2. X is equal to 2's cancel. Remember, 2's cancel here. 7 over 2i plus minus. And another one, solve each by completing the square. Oh, completing the square means we have to have the constant, the x squared minus 8, and the 25 moves to the right side to become negative. And when we complete the square, remember the pattern, for completing the square, what number do we put on here? Well, it's a b divided by 2 squared. Gives you what we call c, the c value right here. So 8 divided by 2 squared is 4. Oh, there's a square there. 4 squared. So that gives us a 16. So that means we add 16 to both sides to balance it. And the factorization of this perfect square trinomial is x. And, oh, this was a negative 8, see? This is a negative 4. Didn't make any difference to the answer. But that's a negative 8 divided by 2. So there's a negative 4 squared, which is 16. So what do we have here before we squared? Minus 4. The factorization of x squared minus 8x plus 16 is x minus 4. Whatever is right here, negative 4, whatever we have right here before we squared, that's what goes there. Because that's, if you FOIL that out, you will get this trinomial here. And that ends up to be negative 9. So we plus minus is coming after. Here comes the plus minus. We do the square root of each, excuse me, square root of each side, plus minus. And x minus 4 equals plus minus. Square root of 9 is 3 with an I. X equals negative 4 moves over to become a plus. So there's one answer is 4 plus 3i. And the second answer is 4 minus 3i. Notice these are conjugates of each other. They are imaginary roots, complex numbers. That's the real part, that's the imaginary part. And we want to solve this one by completing the square, but what we got to do is, again, we move the constant to the right side, make it positive. We divide all terms by negative 2. So x squared plus 6x equals negative 13. And the reason is, when we're completing the square, we want a 1 right here. It makes it easier to complete the square when we have a 1. And a is 1. And we take 6 divided by 2 and squared. That's a 3 squared, which gives us 9. So that's a plus 9 to complete the square. So again, a half of 6, which is 3. 3 squared is 9. So the factorization of this very quickly is an x. And what's this number here? Before we squared, plus 3. So x plus 3 all squared gives you that trinomial when you square it out, and that's a minus 4. So we'll do the square root plus minus the square root. X plus 3 equals plus minus 2 with an I because it's negative. So x equals negative 3 plus or minus 2i. And the two answers, negative 3 plus 2i or negative 3 minus 2i. Right, that's, some teachers will accept this answer. I like to break it up like this, show you that there's two roots and they're imaginary roots. And the last method, notice we practice the factoring, square root property, completing the square. Now we'll review the quadratic formula. Quadratic formula is, we have to have a b, and a c. It has to be written in this form. A is 1, b is 4, c is 4. So x equals negative b plus or minus b squared minus 4ac all over 2a. So we have the negative of b is 4. So b is 4. A is 1. C is 4. All over 2 times 1. which is, so let's go up here. We got a negative. The negative of a 4 is negative 4, plus or minus. Now, if you want to work all this out, I'll work this out. What you have is 4 squared is 16. Then you multiply. Negative 4 times 1 times 4. Negative 16 gives me a 0. And over 2. So that's a negative 4 plus or minus 0 over 2. Negative 4 over 2 plus or minus 0 over 2. So we got negative 2 plus or minus 0. Now notice, as a lot of people say, that you have a negative 2 plus a 0, or you have a negative 2 minus a 0. So really, there's only, some people say there's only one root, but that's true. But every quadratic has 2 roots. So if there's a root of negative 2, the other one, if there's no other, must be a negative 2, because it has to have 2 roots. Yes, there's a negative 2, but there's 2 of them. And to illustrate that, let's do the factorization on this. This is, watch, x squared is x and x. Factors of products of 4 and the sum is 4. It must be plus 2 plus 2. So notice this is x plus 2 equals 0. X plus 2 equals 0. So x is negative 2 and a negative 2. Oops. X equals negative 2. X equals negative 2. Because the 2 factors are the same, the 2 roots are the same. So not, ask your teacher about that. We have one root of negative 2, but there's a double. There's 2 of them. Check that out. Because notice when you discriminate, you'll see I'm going to do a unit now coming up on this. When the discriminant is 0, we have the same root twice, because this is a perfect square trinomial made of the 2 factors the same. Check it out. X squared minus 4x plus 3 equals 0. And we're doing the quadratic form A, B, and C. X equals negative b plus or minus b squared minus 4ac all over 2a. Again, b is negative 4, so it's the negative of a negative 4. B is negative 4, so it's a negative 4 squared minus 4. A is 2. C is 3. All over 2. A is 2. So that gives us the negative of a negative 4 is a plus 4. And if we want to work this out, again, rather than write it all down, I'll just get one number. Negative 4 squared is 16. And I have 4 times 2 times 3. That's 24, negative 24. That gives me a negative 8 all over 4. And let's go up here. So we get 4 plus or minus square root of 8. 8 is 4 times 2, so it's a 2, root 2. But because it's negative, it'll have an I all over 4. So we can't add or subtract these. So we go 4 divided by 4 plus or minus 2i root 2 over 4. So that gives me 1 plus or minus. So 2 into 4 goes 2. So we get 1/2 I root 2. Or you could say I root 2 over 2. So that's 1 plus 1/2 I root 2. Or 1 minus 1/2 I root 2. And we solved it by the quadratic formula. And notice the number here is negative. Notice the number here is 0, so there's going to be 2 roots. Number here is negative, so it's going to be imaginary roots. And number 3, we're going to solve and check. And we're solving and checking it by the quadratic formula. So A is 1, B is 2, C is 2. So x equals, C. I said C and wrote down a B. X equals negative b plus or minus. And again, if you followed all my videos so far, you have this formula down pat. You should write it down and down and down until you fully write it down correctly. 100% of the time. So we have b is 2, so we have the negative of 2, plus or minus. B is 2, minus 4. A is 1. C is 2. All over 2 times A, which is 1. That gives us negative 2 plus or minus. And what does this work out to be? Well, let's work it out up right here. 2 squared is a 4. Multiply, we get negative 8. And that adds to give me negative 4. So that's negative 2 plus or minus. Square root of 4 is 2, but it's an I because it's negative. All over 2. So we can't add, so we go negative 2 over 2 plus or minus 2I over 2. Negative 1 plus or minus I. So there's 2 roots. Now we're going to check each root. So let's check when x equals negative 1 plus I. And we're putting it into this equation. So I'm going to sub negative 1 plus I into x into this equation. Negative 1 plus I squared. Negative 1 plus I plus 2 equals 0. So you just take your time, and that's a square, so I'm going to multiply by itself, by FOIL. So I wrote it down twice to make sure. So here we go. That's a negative 1. Negative 1 times negative 1 is 1. Negative 1 times I is negative I. I times negative 1 is negative I. And positive I times positive I is a positive I squared. And plus 2 times negative 1 is negative 2. Plus 2 times I is a plus 2I plus 2. And notice that I can cancel those. I got a 2I and a positive 2I, so they can cancel. Now notice I have a 1. I squared is a negative 1. So I squared is negative 1, so 1 minus 1, 0 equals 0. So yes, negative 1 plus I is the root of this equation. Now I'm going to work out 1, negative 1 minus I. Notice that these two numbers are conjugates of each other. They're conjugates. And conjugates, you change the second sign, not the first. So we sub that in. Oops. X squared plus 2x plus 2 equals 0. So I have this root. I'm going to sub it into this equation. So we have it. Negative 1 minus I squared. Negative 1 minus I. So notice I took this root, negative 1 minus I, put it right here in the place of x, put a bracket around it, and positive 2x, so this is negative 1 minus I. Now I'm going to square, means multiply by itself. We just take your time. And I get it all written down, then I'll do PEMDAS. So now I multiply here. See, when you got a square, you should do this first, but really, if I expand this out, I'm going to multiply these two, then multiply these two, and add at the end. So here we go. Negative 1 times negative 1 is 1. Negative 1 times a negative I is a positive I. And a negative I times negative 1 is a positive I. Negative times a negative is a positive. I times I is I squared. 2 times negative 1, negative 2. 2 times negative I, negative 2I, and plus 2. And notice we have positive 2, negative 2 cancels out. That's a negative 2I, but positive 2I, they cancel out. And again, we have a 1, and we have a positive I squared, which is I squared is negative 1. So that gives us a 0 again. I squared is negative 1, which is in my unit on powers, when we work with imaginary numbers, the second video in my imaginary number section. Not to practice, and then because we practice the imaginary numbers, the complex numbers, it makes the working out here easier to do with the eyes. So that's a review of all the systems, all the methods that we solve the quadratic equation for. And if you like my video, click the like button, subscribe button, and notification bell. More videos are coming. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's going to be on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.